Thank you for inviting me here to speak to you. It's been a very interesting morning and kind of set the stage for a lot of what I'm going to talk about today. And mostly use cases and the data that's made available from the networks and how rich that is. And what I'm going to propose to you is that location is going to be one of the key frameworks that will allow you to derive value from this data that's being generated. Here is a division of Nokia that makes maps, and we make services that are built on top of maps. And I'm very happy that your example this morning was not related to our maps, because Johannesburg is actually on our maps, so that's a good story. So maps are what I would propose part of our DNA. We've been making maps since the dawn of time. We need to understand where we are, what's around us, how to operate in the environment around us. And as we explored our world, our maps became more interesting, more extravagant, more detailed. We go places where we can't even drive, we can't even ride our bikes. We hike places to make maps about our environment. It's part of who we are. We even send drones out to map sides of mountains to go places where we can't go so that we can explain our world. Now we're starting to put digital and those old paper maps together. We've got maps, our here map. Can we dim the lights just a little bit for us? So that you can see the detail here. So you can put photorealistic buildings on top of our digital maps. So we can go way beyond that 2D map that we've been using in the past. I used to work for OnStar 15 years ago. I'm dating myself now. Life was a lot different then. I wasn't around for that. That was the first telematics system deployed in the US market in an Oldsmobile 88. But OnStar delivered one of the first consumer-based telematics systems in the US, and we delivered it over analog networks. And we were limited by, we had so many ideas we could do with telematics, but the network wasn't there for us. So life is changing, obviously, thanks to the pervasiveness of mobile phones, mobile devices, and we've got these ubiquitous data networks that we can do so much more with. So what's happening? Internet of Things, and I'm including not just small consumer devices, phones, cars, all of these things are coming. They're giving us local activity. They're giving us geospatial information. That is creating big data. So now we've got huge amounts of data coming up to the cloud. Way too much, might I add. We have to get smarter about it. So what big data is letting us do is build these models where we can discover using those models, and we can predict now. We can take history and we can start predicting based on these big data models. But I'd claim that also to bring value to us as human beings and to the things we're doing, you need a hyperlocal perspective. I need to know just what's around me. The world is full of complex data, but I don't care. I only care about what's around me and what's happening around me. So that's what makes it humanistic. That's what makes it relevant. And this is all happening now because of the networks that you guys are building. And it's just fabulous. As a data person, I'm just soaking up all this data. It is so rich. So think about a map as a kind of a representation of geospatial extent in 3D. And then you also have all this annotation building up on top of those maps. What's happening on the map, what time things are open, where the events are, what the transit looks like, what the traffic looks. It's all building up on top of this location framework. And then, because of all the computing capability we have, we can capture it in time. So that's where we get even more rich data. So what we're doing is we're taking location, a lat long, and through this rich annotation, we're turning it into places. We know what time that restaurant opens. We know how popular it is. We know what kind of mood is there, what kind of people go there, what the demographics are. So we're capturing all this information constantly now by virtue of the networks and our computational capability. So from a restaurant perspective, just as an example, we could track the popularity. The restaurant opened, had a great chef, lost its chef, popularity went way down, came back up again, and so I know the history of that place. But maps are morphing into something completely new. Those 2D flat maps are going to go away, and they're going to become companions and advisors and assistants for me to go through my daily life, my mobile life. And all these devices are listening, tracking, reporting, and creating a large amount of data. Now, in the past, we've done some really clever things to try to simplify all the complexity of this data, this location information around us. The tube map, a perfect example, that folds up and fits in your pocket. Some of them not so good. Way too much cognitive load in these things. So how do I simplify this data and make them relevant to you? So, for example, in that restaurant, I only care about whether it's popular now. I don't care if it was popular a year ago. So now hyperlocality is becoming a key part of the applications that we have to build to give you the information you care about. Another key part is hyperlocality is dynamic. It depends on your situation. And it's a hyperlocal environment around me, and then combine that with my personal preferences and the state I'm in, what I'm trying to do, that defines context. Context is a key part of applications as we go forward in order to provide value to you. This is an example of a neighborhood messaging system that my partner and I designed. It's a philanthropic endeavor, so this makes no money. But the neighborhood messaging system was designed to create a hyperlocal environment around me. So at my address, I can speak to people that are within a distance around my home. But what we set it up to do was people can forward their messages. So this is an example of a message moving through the neighborhood. Unfortunately, somebody was mugged in our neighborhood, which is not good in Oakland, and posted on the messaging system. And as a result, the neighborhood decided what was relevant and moved that message through the system to let all the other neighborhood subscribers know what happened. And that was relevant to those people only. It didn't go much farther than the local neighborhood, even though the system is across all of Oakland. So hyperlocalism is really key going forward. So our devices are sensing, and they're creating all this rich information. And let me show you some of the really interesting data that we get from this. It's a shame we can't dim the lights because this is really rich. This is cell phone data for the city of Austin. And it's colored by speed. And you can see the richness of the data here. Down here, that's the Austin airport. You can see them coming in and dropping people off at the luggage place. You can see a mall right here. You can see downtown Austin is nice and low level buildings, so we don't have the fuzziness that you generally see from GPS data in a urban environment. But you can see the richness. You can see, all the interchange information, where stop signs are, stoplights are, all kinds of rich information embedded in the data that you're creating. This is 1 day's worth of data from January 1st in 2014. Most people in the US are sitting at home watching football games that day, but you can certainly see a lot of activity. Again, it's colored by speed. So red is slow, blue is fast. What was interesting here is this, up in North Dakota, where there's not many people living up there. It's a lot like Sweden, I guess. That natural gas industry, they don't take the day off on January 1. Another interesting part, which you can't see because of the resolution of the projector, but I have a red line going right through here. It's crossing 4 states. Red is slow. That's garbage. This is big data. Big data defines what you can do with the data defines what you can do with the data. And these are coming from multiple devices, and you will have garbage. This one's easy to filter out, but a lot of them aren't. So data analytics are going to be key to being able to make use of this data. And I can show you all kinds of other interesting examples in the data. And this is a visualization tool that we had to build in order to get this much data on a screen. And it's just a slice of the data. It's not a lot. It's 78 million points here. Here's an example of how we take that probe data. This is probe data in Oakland. And what you'll see here, we've done some signature analysis on the data, on the tracks. And the data is building up the color-coded ones. The blue ones are one that shows start, stop, start, stop, start, stop. Red ones are where they linger in space and time a little longer. What you're seeing here is a manifestation of a drive-through lane at a McDonald's restaurant. So now you can, from this data, start to build attribution on places just from the data itself. So if you're traveling and you want to drive through McDonald's that's not inside of a Target or a mall, then I can tell you which ones have drive-through lanes just from the data itself. So these sensing and communication channels are creating new business models. Big data analytics is going to be a key part of it. Here's an example of our map with our ADAS information layered on top. So the map this is the road segment here. The red lines here show the curvature of the road. That's part of our advanced driver's assistance information, so the vehicle can use this information about the curvature of the road. Scattered about here, of course, is all our GPS points that we're collecting. Now you can imagine, you can go, if you get more sensors from the vehicle, here's the braking pattern of people as they're coming through the curve. So the histogram is the number of people that brake. The color of it is the speed at which they brake. So now we're starting to understand how people actually experience the roadways. And you can imagine how important this is going to be for highly assisted driving and autonomous cars as we move forward. Here's another example where we were taking a look at the windshield wipers. Just in a small city of Eindhoven, looking at the windshield wipers, you can imagine a vehicle that could potentially, through V2V technology, communicate to other vehicles. There's a rainstorm up ahead, slow down. It's dangerous. Or this fellow over here is experiencing a little rain. This is a localization of the rainstorm. If he's heading over here, then we can reroute, and he doesn't need to go through the storm. So lots of information in this data. Here's another example of people coming into a very sharp curve where they started braking. This person decided to brake very late. I like to think about him sitting in a tree somewhere here. That's why you want to use the wisdom of crowds for driving. You don't want to just take any trace off that map. You want to take the generalized trace. So we take the centroid, and actually if you look at, I did look into what happened to that person. These are colored by speed, and they're coming through the throughway. They're starting to brake right here. Slow down, slow down, slow down, accelerate out. But for the gentleman that decided to take it a little bit faster, he made it out of the curve, which is a good story. But in fact, didn't even recover until way down here, probably recovering himself as well as a car. So again, that's why we need the wisdom of crowds for driving. Now, an important part of this is we can annotate this on top of the map. And they say it takes about 10 years to learn how to drive. So think of your teenagers out there. If they have that kind of information, that can say you're entering that curve just a little too fast. Maybe it's time to slow down. Then they've got that advisor with them at all times, and it can be communicated in their vehicle. So big data analytics is interesting. You learn a lot about dynamics and behavior. It also allows us to move forward in time. So this is traffic data from San Francisco. And what we did is we took 2.5 years of data and built models so that we could predict what the tides of the city are. I call them the tides of the city because the city kind of generally works the same. Not every day. It has a pattern every day of the year. It has a different pattern on holidays. It has a different pattern on weekends. But you can pile up 2.5 years of data and build very, very good models for it. And so here on the right, which is hard to see again with this lighting, is it smooths it out and lets you make generalized understanding about the tide of the city itself. So our devices are morphing. We're getting all kinds of structured, unstructured data, which gives us the big 5 V's of big data analytics. And I would suggest that the biggest V in those 5 V's is value. Because big data is a lot of work, and a lot of people have spent a lot of money working on big data, and it takes very sophisticated algorithms to extract value from it. So going forward, I think this is the challenge that was set forward, is that edge computing is going to come. It should come. And that is going to change the way we think about computing. So I come from a high-performance parallel computing background. We are going to have to distribute, we are going to build our applications very differently if we really get to this level of computation. So understanding where computation belongs on the device itself, at the edge, up in the cloud, where this computation occurs and how you distribute it and how you control all of this information is going to be a very challenging problem going forward. I liken it to parallel computing. When parallel computing first came out, we were all excited about it, and it took a long time for it to really provide value. I think we're going to have the same challenge here. So you can imagine in traffic management systems that this whole edge network now can play a whole new role in how you manage traffic in environments. And you can have the nodes, doing some of the telematics work if you want to. They're involved in the telematics process, but there's all kinds of things that could be thought about as this edge computing rolls out. And that doesn't mean that there's no role for the cloud, because the cloud is an aggregator, and it's going to take all this information up and do a higher level aggregation on top of this location framework. Very interesting problems to be solved, I think. So, so as I mentioned, understanding context is where this value creation is really going to come from for mobile, because you're going to want to know what's important to me, and I need to reduce your work in order to take advantage of maps and all the information that's available. So when I talk about context, I've got a very complex cityscape here, but as you're walking through the city, you really only need to know what's around you. And if I'm an antique buff, I may want some of these little shops here to light up as I'm walking through the city to say, hey, there's an antique store here. Or, hey, there's one of those favorite restaurants that you've been looking for, and it's right here as you're walking. Now, as you're walking through this complex city environment, you're going to catch a train. So I really want, when I get into the train station, for that map to morph into a train station map, so that I know where I am on the train, where to transfer my trains to get to my destination. And once I come out of that train station, I want to morph it back into the city so that I know where I am. So the next last piece to this is little data. So we've got huge amounts of data out there, and now I'm going to have to extract out of all of that data what you care about. So now I've got the little data problem. I've got to slice it out and find the things that are relevant. So for example, here's this city of Chicago. It's got a gazillion POIs in it that you might be interested in, but actually you're not. You're only interested right now, my state, is I'm interested in having either a coffee or a cocktail, depending on my state of mind. I only want to see my cocktail and coffee places. And then what I'd also like to do is capture on top of this map, this location framework, my history with those places. So I've been to this whoops, sorry. I just went dead. There we go. I'm back. So I want to capture my history at that location. So I want to be able to swipe on my mobile phone and say, I love this one, and I want to swipe down when I don't like it, so that I'm capturing my history. And then I want to combine it with your history, because we're going to go have a cocktail together. So here's you're purple and I'm green. And so now I want to put those two worlds together and be able to say, that appears to be our favorite martini bar right here, because we both love it and we've both swiped it up. So that's the little data aspect of pulling all this information out, making it available to you when you need it. So as we've talked about, this ecosystem is forming. Time to start thinking about taxonomy of devices. We've talked about it already. You know, there's stationary, there's mobile. There's things where it's location irrelevant. There's things where that are location relevant. I would suggest that we're going to have these things kind of sliding over to location relevant, so that Fitbit knows I'm riding a bike when I'm on a hill, for example. Cars are coming. There's no question about it. It's a sophisticated sensing device. As I said, I worked for OnStar before. I come from the auto business. They're putting amazing sensors in vehicles now, radars, cameras, lidars, all kinds of things. But it is not a consumer device. So for those of you that might be working in the area, always remember it is a deadly weapon when people are distracted. But what's really lovely about a vehicle is it has a big, giant battery, which we love. So there's a new class of applications coming, big data doing the contextualization. And to fit into the forming ecosystem, I believe you're going to have to think about all these different things. Networks, of course, providing the capability of all of this. Next generation cities, things out of your location to get you out. We'll have mobility as a service. We'll have dynamic transit lines that are forming based on demand. We're going to have sharing, pooling, all kinds of interesting business models coming out. Delivery as a service, just-in-time groceries, the one-button click above your dishwasher liquid, so that you just push the button and Amazon immediately refills your needs. And then I think the third piece, of course, is to make it all fun. And so we have all kinds of social as a service coming up with things like dinner for six and things like that. So in conclusion, this is 180 million probe points rendered, very hard to do. But we've got all that data. It's only a tiny slice, as I said, of the data that we have available. But I have to make it relevant to you. And I have to come down to your home. I have to be able to understand what you're doing in the morning, and you're dropping your child off at daycare, and you're going to the store, and you're heading off to the transit station. And then you're going to go to work, and then you've got to come back and get your groceries on the way back. And you've got to start to build this environment, contextual environment, hyper-local environment around the individual to really build the value. So with that, I'll say thank you for listening.
Thank you, Jane, for a very inspirational talk. Comments or questions?
I've left them speechless. Can't be.
Kari.
Okay, this may be one of my favorite topics, but I see 5G not only as a new communication system, I also see it as a kind of new system for localizing people and sensors with unforeseen accuracy and very low power consumption. So how important you would see kind of 5G providing this kind of service and not only be seen as a communication network?
You would make my life so much better. As you saw probably earlier on that one slide, it's hard to see in the lighting, our location data is not good. And my team has to do a huge amount of analytics for map matching to figure out where you are, and for just understanding activity. And the better understanding of exactly where you are, huge difference. And also, I think one of our bigger challenges was not quite related to that, but makes my world really challenging is privacy. Because all the data that you see here, any of those cell traces, they're all chopped up for privacy. So, and I can't put them back together again. So I have to be able to do localized analytics. I can't follow somebody all the way from home to work. So the more location accuracy I get, the much better those analytics can operate.
Okay, I think that's a theme, the privacy issue we can come back to in the panel discussions. Well, I guess that's a question you probably get 500 times a day, I guess.
Yes. We do not collect information.
Yeah, right. So it's okay if my local neighborhood store knows what my preferences are, but I'm not sure if I want Google to know.
Exactly.
Okay. Thanks again.
My pleasure. Thank you.